So here we have triangles. Oh my gosh, we're so familiar with triangles. Triangle just means that you have three angles in your shape, right? Triangle, you have three sides also. And we usually label those sides with the letters, just like on the Pythagorean Theorem with right triangles. Yeah, we can use the same exact letters. We've got an A, a B, and a C. Ordinarily, the B refers to the segment which we call the base. Now, on this particular shape, the base is drawn on the bottom, but it doesn't have to be. Okay. However, whatever base you have, its height has to make a right angle with it. It has to be perpendicular to it. Always that relationship will hold true with any of these shapes. Bases and heights have to be perpendicular. Okay. So we have a triangle with side lengths A, B, and C, base B, and a height H. Nice. So the perimeter formula is just simply my A side plus my B side plus my C side, right? There's nothing spectacular or special about that. I just add up the three sides. All right, fine. My area formula is 1/2 times the base times the height. Sometimes you see this written as just simply base times height over 2. It means exactly the same thing, right? Okay, so again, remember that perimeter will be in units and area will be in square units. So let's take a look at our problems for triangles. So on number 1, this one is the one that is sort of straightforward. Find the perimeter and the area of this triangle. We have a right triangle, and it's green, which is important. Number 2, solve the triangle area formula for 2. Okay, so this sounds and looks sort of like what we had to do for the parallelogram problems, because there's no 2 in this formula except for the 2 that's right down here at the bottom. I think we can handle that this time. And then finally, number 3, write a formula for the area of a right triangle in terms of its base B and its hypotenuse C. If you say so. All right, let's go over here where we have some space to work. You know what? Since that triangle's green and it wants our problems to be green, it's going to be green. Okay. Perimeter. Perimeter of a triangle is just the sum of the three sides. It's A plus B plus C. The problem is I don't know what A is. It is, however, a right triangle, and as a right triangle, I can use the Pythagorean Theorem on it, and I, of course, do not have enough space. And if you look at my battery, I may not even have enough battery. Who knows? We'll see how it goes. All right, so Pythagorean Theorem, remember, we have an A, we have a B, we have a C. It is just C squared, that's the hypotenuse side, it's always the one that's across from the right angle, is equal to an A squared plus a B squared. Scribble. There we go. Yeah, so I'm going to use the numbers that we have here. The C, it's the biggest one. It is across from the right angle. It's the 1.3. Is equal to my A, which I don't know, A squared, plus my B is this 1.2 squared. All right, and I'm going to square the pieces that I can. So think of 13. Ignore the fact that you have a decimal in there. So 13 times 13 is, I think it's 169. And I'm going to move my decimal place over 2 places. And again, the reason why is because you have 1.3 times 1.3, and you got a total of 2 decimal places to move. That is equal to A squared is equal plus, so 12 times 12, or 12 squared, is 144, so that'll be 1.44. Okay, and let's see, then what am I going to do? I think I'm going to subtract, right? All right, so I'm solving this for A, so I need to get A squared by itself, so I'll have to subtract this 144 over here. That's not 144. Right. All right, cancels over there. That's nice. And let's see, this is going to be, looks like it's 0.25. Right, so 9 minus 4, 5, 6 minus 4, 2. Bring down the decimal place. If you want to, you can put a 0 in front of that, is equal to A squared. Okay. And then the last step of any kind of Pythagorean theorem situation is you got to take the square root, right? I have A squared, it's quadratic, so undo that square, I'm going to take the square root of both sides. And as I may have mentioned in another video, I'm supposed to get two answers here, a positive and a negative. But here I'm going to throw away and completely ignore the negative one because it's a side length. It's how big this side of the triangle is, and it's not going to be a negative number. So the square root of, ignore the decimal, 25. What's the square root of 25? The square root of 25 is 5. Now I just need to think about the decimal here. Is it 0.5? Is it 0.05? What's it going to be? Okay, so if it was, say, 0.5 times 0.5, like so, 5 times 5 is 25, and then I have to move the decimal over a total of 2 places, which would put it there, which is exactly what we have, right? Again, you can use the calculator if you're not confident about it or if you wanted to check to make sure that you were doing it right. And then on the right-hand side, the square and the square root should cancel each other out as inverses. So here we have our a value. Get rid of this. Put in a 0.5 on it. It is also in inches. I'll take that into account momentarily. So our parameter is equal to my A, 0.5, plus my B, 1.2, plus my C, 1.3. And then add up all of these things. Let's see if we can tackle this without a calculator here. So adding up the whole numbers, I have 2. Whoop, whoop. And then adding up all the decimals, I got 5, 6, 7, plus 3 more is 10. So it's like I have 1 more, plus 1, gives me a total of 3, right? Okay, yeah, so I've got a perimeter of 3 somethings, and those somethings are in inches. I think red would look really good in Christmassy together. All right, lovely. Now let's calculate the area. In the area formula of a triangle, very easy, is 1/2 base times my height. Area is equal to 1/2. My base length here is the 1.2, and my height here is this 0.5. How do I know that? I know that because those are the 2 segments which make a right angle, so they are going to be considered our base and our height. It honestly doesn't matter which one, like the 0.5 or the 1.2 is the base. I'm going to multiply them, and the order of it is not going to matter. Okay. All right, so I am going to multiply, simplify these problems, these numbers like this. Watch this magic. This 1/2 that's out front, it's not a distributive property. As a matter of fact, what I can do is I can take half of one of these numbers. And since the 1.2 is, it's even, it's easier to take half of that number than it is this one. So that's the one I'm going to take half of. So half of 12 would be 6, and then I need to make sure that I preserve my decimal place that's right there. And now think of 6 times 5. 6 times 5, of course, is 30. But I need to move my decimal place over 2 places, so boop, boop. It would be right there, it's 0.3. 0.3, I have inches times inches. I need to have inches squared as my answer. It's squared inches. And an official red box. All right, I'm going to ask the same question again. I may have fooled you the first time. Let's see if I still fool you. Hey, which is bigger? The 3 inches there or the 0.3 inches squared? That's right, you can't compare them. You didn't get fooled this time, did you? Sure, even though the number 0.3 is smaller than the number 3, they're 2 totally different concepts, 2 different kinds of measurements. They don't really compare. Okay, let's look at number 2. Solve the triangle area formula for the number 2. Okay, so as we've looked at in some of the other problems, I want to highlight the fact that I am looking for a triangle area formula. Ignore the 2 for right now. So let's go ahead and write down that formula, which is area is equal to 1/2 base times height, okay? And then we want to solve that thing for 2. So I can't directly solve for a 2 here because there isn't a 2 in the problem. There's a 1/2, and the 1/2 has a 2 in it. So that's going to be an intermediate step. We're going to solve this thing for 1/2, and then when we're done, we will do some math in order to turn that 1/2 into a 2, okay? So the 1/2 is currently being multiplied times both b and h. You can get rid of them separately, but you can take them as a group because it's only multiplication over here. So to get rid of that quantity, we could just divide both sides by BH, and it's going to get rid of it on the right-hand side. So I'm going to divide both sides of this by BH. On the right-hand side, A divided by BH, there's nothing that simplifies there because there are no like variables. However, on the right-hand side, the BH's cancel because BH divided by BH is 1. And then I'm left with 1/2. So we did this in the parallelogram video. One of the things that you can do with a proportion is you can just take the reciprocal of both sides. So I can very easily just switch these two and make that b over h over, no, b times h over a is equal to, make 1 over 2, 2 over 1, otherwise known as just 2. And if you would like to write 2 first, 2 is equal to bh over a. Did you know that that's a very strange way to get the number 2? You look at a triangle, you take its base, and you multiply it times its height, and then you divide it by its area. You'll always, no matter what, you'll get the number 2. That's crazy. That is just absolutely weird. Now, that's not the only way that you could have done this particular problem. Like, for example, on this step, we could have cross-multiplied. So it is a proportion, so you can cross-multiply it and get this cross product as 2 times a. And then on the other cross product, it's bh times 1, which is just bh. And now if I'm going to solve this thing for the number 2, I need to get rid of a, which means I need to divide it to that side because it's being multiplied times a. So if you divide both sides by a, divide both sides by a, a's cancel on the left-hand side, and then you can see we got exactly what we had the first time. All right, let me check the time here. Sorry, 10. So I'm going to pause it for right now, and we will pick up number 3 in a separate video.